So, now that I know what the range is, the next thing I need to do is I need to figure out what the zone loops thing here is. Yep, this is how many loops there are within each zone. The 0 is for this going to this. The 1 for this going to that. The 2 for this going to this. All of the best speeds, basically. Then the 3 is for all the upper end of the good speeds, and 4 is for the upper end of the other speeds. Of course, obviously, wise to save frequently. That helps a lot. So, I need to determine how many loops there are. And you might be wondering, what does this sound like? The 175 or 17 and a half. Okay, well, I'll show you. A little math in my head. Yeah, literally, that slow. Ready? You can barely even hear anything. It's just so slow. But for this, what I need to do is I need to find the logarithmic average from this to this. Or geometric mean, as it's actually called. I just call it logarithmic average because, well, when you're looking at a logarithmic scale, the halfway point is not what you think. Okay, what's the halfway point between 6 and 10? Just for a quick example. You might be thinking it's 8, but logarithmically, it's something around 7.6 or so. I'm not entirely certain. It's probably more like 7.7, but yeah, I would have to punch in the calculator. But either way, I need to find the logarithmic average between this and this. And a quick mental estimate, let's see here, gives me 25? It's around the 25 area, I would have to say. But one way to really make sure, how do you do a logarithmic average? It's real easy. You take one number, multiply it by another, and then you simply take the square root of that. Raise it to the half power. And that's basically a real result. And hey, 25k, what do you know? It's pretty close to that. It's basically just like your linear average that you're more familiar with. You know, like 6 and 8 becoming a 7 instead of 6.8. Yeah, your linear average is the kind of average you're most familiar with. It's just basically upgrading operations. Changing add to multiply and divide to a square root. I call it upgrading operations. Let's see here. Yeah, which one is it? I need to use this one here, and I set it to, well, in this case it would actually be this, because 50,000 is the original, because it's based on 1/4. However, it's over 14 minutes long, which is way more than what I need. So, that one's actually good as is. Next, I otherwise just keep repeating this process until I'm done. Of course, I can drop the zeros and stuff at the end. Let's see, a quick mental estimate, just to give you an idea. Let's see, 46.5? Oh, okay, so it's about 46. I'm just estimating. Not that one. 46 would mean I need to use 23. It doesn't have to be exact, it just needs to be close. And this is already long enough, it's 7.5 minutes. So, skip that one. This is why I have a 2 in here, because it's almost always a 2. Now, for the best speeds, well, this is where I use the 60 to 100, and I think that's the 77. 60 times 100, if I had just put 2 zeros at the end, raised to the .5, and it's 77.5. Let's see, that's 385. Here, I'm not too sure exactly if that otherwise qualifies. So in this case, what I do is I select this entire thing and I copy it. This is the loopable version. And I append this to the end of here. I note the duration. It's a little less than 7 minutes. So in this case, I look at my notes here. So in this case, 4 to 6. The intro isn't very well liked. So in this case, it would be more toward the upper end. So this would otherwise qualify as a 3. So I can keep that as is. Now I got the 100 to 180. I have to add the 2 zeros at the end. And it would be 134 or 67, which is easy enough to do. Of course, I Z that out, undo it, because I need the original so I can find out more precisely. Okay, in this case it's 4 minutes. The good zone maxes at 4 minutes, so 3 it is there. And the other zone is meant for experimentation. So let's see, I know that's 540 with 2 zeros at the end. Raised to the dot 5. And divide that, and I got a problem here. Let's see, that'd be 58 that I would use, and I just simply double the time. Other is based on 2 minutes. Z that out, and I used 58. And let's see, that puts it at 430, but since this is half, it would actually be 215. I would have to say that's pretty close. So in this case, I would put a 3 here, and that concludes that part of the process. And now I get the frequency changeover points. Now what's that all about? First, I need to get this, Z this to its original state. I need to get this to 50,000. Of course, get the whole thing in the view. And now, to get this, I need to use the spectrum. See the top part right here on this? I need to get this all the way up to the very, very top here. So to do that, I change the speed so that it's actually faster. And let's see, that looks like a huge jump I'll need, so I'll try 70 for 140% true speed. Okay, still got some room to go. What speed should I try? It's just a trial and error type thing. 75. No. I'll try 77. Ooh, that is really, really close. So now I know it's 77, 154% true speed. To determine that, I use 154, the percentage of true speed, times .24. So it's basically 37. So I go up into here and look at what I got here. 36, there's 37.5 that I could add. So what's with all this here all about? Well, this is based on when the MP3 files use a different sample rate. These are the sampling rates that are used for the MP3 files. After all, there is no point in using something like this for when they're the 48 kilohertz, which otherwise maxes at 24,000 hertz for the sampling or actual pitch, when there's no point in using something that high when the highest in the song, because of speed change and stuff like that, is only 5 kilohertz. So that's why I use something like the 12. Yeah, this may seem horrible, but you'd be surprised. So that's basically where that comes from. And this is where, remember this here, on how I got that times 24 at the end? Well, that's where that comes from, and that's where this originates. But it looks like I might have to add another one of these in here, because I have a 37.5. I set it so that's always a multiple. It has to be a multiple of 3 at least. But I use 1500 just for simplicity reasons. This is otherwise just copied. And this is 4/3 the previous. 4/3, I would actually make this a convenient 50,000. This is double, and there would be that. So that would be what I would use. So, and that otherwise concludes that part of the process. Now the next thing I need to do is, of course, well, this is the previous system that I used, just for reference. I changed my program because getting this was getting rather tedious, and I had to keep changing all this stuff every time I had to make even the slightest change. But things are now much easier, because all I got to do is just simply change this one parameter. And let's see, this is FF6 world. Make sure something comes up, because otherwise I'm just going to get errors, and then the program won't even run at all. So, that otherwise pretty much concludes this, except for one thing. Well, you want to see the program? That's weird. So how come nothing came up? There's actually a reason for that. I need the base file. Base file? Okay, source files. Notice how all these end with base and stuff like that? Notice that there's nothing for Final Fantasy VI World in here at all? That's why the program didn't run. It's because I didn't have that. But creating the base file is actually very easy. First, get this to true speed. That's a must. And also a must, this must be 50,000, because otherwise it's going to take a long time to save, and it's going to otherwise change the waveform itself, and they can't have that happen from changing the speed. So, I need to, however, I had the 2 and the 3 in here, because I got some 2s here, and then I got some 3s here. So, what is that all about, and how do I control that? Well, if you look here, you can see a number at the end. There's a 2, a 5, there's a 7, a rather ridiculous 66, because that's a 3-second loop. So, and in this case, I just keep the full name, get rid of the GB, but I have to have base, and then a number at the end. That number is the number of loops. This is the version with 2 loops. That went by very fast. Okay, so this, I already got the, I don't think I have it on the clipboard anymore, so I'll just copy it just in case. And now I'll just simply append that to the end and save this, except this would have a 3 at the end. And of course, if they're really close together, then I may end up changing some things on here. What do I mean by that? Okay, here is a good example. Would be 2, 3, 7, 6, 5. There are so many similarities, and they're very close together, and so I figure I might as well, instead of having 5 base files hogging up disk space, I just reduced the number. So I just put this as a reference. But in this case, there's quite a difference between the 2 and the 3. But there isn't much between the 7 and the 6. I think it's 25% is the difference basis. So 4 and 5 would be about the closest, although I think even that's a little much. And I usually tend to round down, because smaller file size, more that I can fit more in my MP3 player when I get there.